So today we are going to speak about a very familiar device, that is pulse oximeter. You all might have seen this device when visiting the hospital, or you might have used it at your home. So today we are going to see the science behind this device. So this pulse oximeter has a red LED and an infrared LED. Please don't mind the spelling. Infrared LED on one side and a photodiode on the other side. When the red light and the infrared light passes through the finger, some amount of light is absorbed. It can be absorbed by the skin, it can be absorbed by the blood, it can be absorbed by the bone, and the rest of the light is transmitted and is detected by the photodiode. That is, if we dive a little more deeper, the blood uh, hemoglobin in the blood has both oxyhemoglobin and deoxyhemoglobin mainly. This oxyhemoglobin and deoxyhemoglobin absorbs light differently. That is, oxyhemoglobin absorbs more of infrared light, whereas deoxyhemoglobin absorbs more of red light. So by calculating this difference, the amount by calculating this, how much of red light and how much of infrared light is absorbed by both oxyhemoglobin and deoxyhemoglobin, we can in turn measure the amount of oxyhemoglobin and deoxyhemoglobin. It will be clear in the following slides. So the pulse oximeter works by shining two types of light, that is red light and infrared light, through your finger. These lights are absorbed differently by oxyhemoglobin and deoxyhemoglobin. Oxygenated hemoglobin absorbs more infrared light and less red light. Deoxygenated hemoglobin absorbs more red light and less infrared light. A photodiode on the other side picks up the whatever light makes it through, and by comparing how much red versus an infrared light is absorbed, the device can figure out blood's oxygen level. The underlying principle is of Beer-Lambert's law. So I will explain what it is. First, about the Beer law, that is, the amount of light absorbed by a substance depends upon the concentration of the substance. So when a light passes through this finger, if the amount of hemoglobin is higher, more amount of light is absorbed and less amount of light is transmitted. Similarly, if the amount of hemoglobin is lesser, less amount of light is absorbed and more amount of light is transmitted. So Beer's law states that the amount of light absorbed by a substance is proportional to its concentration. So in this context, it helps in estimating the concentration of oxyhemoglobin. Next is the Lambert's law. Lambert's law states that equal thickness of a material absorbs equal amount of light. So that means if a thicker substance absorbs a thicker amount of a material absorbs more light and less amount of light is transmitted, whereas a thinner material absorbs less light and more light is detected. That is, uh, the thickness of blood flowing through an artery varies with each heartbeat. That is, during the contraction, more amount of blood flows through the artery, and during relaxation, less amount of blood is flowing through the artery. So this helps the device to separate the pulsatile arterial blood from non-pulsatile tissues like skin and bone, because the thickness of skin and bone is not going to change, whereas the thickness of blood in the artery is going to change. So that helps in differentiating the arterial blood from other things like skin and bone. So once the light from the LEDs reaches the detector, we can see what happens after the light reaches the detector. So this is a photodiode. What does it do? It changes the current. It changes the light into a tiny electrical current. From the photodiode, it passes through a transimpedance amplifier, where from which converts the tiny current signal into a voltage signal. So first light is converted to a current, then the current signal is converted to a voltage signal. So from the transimpedance amplifier, it passes through a low pass filter. From the name itself, it filters up the high frequency noises. From the low pass filter, it passes through a high pass filter which removes the low frequency noises that which arises from the hand movement, etc. From the filter, it then passes through the amplifier. What, as the name suggests, it boosts the signal. From the amplifier, it then passes through a analog to digital converter. It converts the analog signal to a digital signal. This digital signal is then passed into a microcontroller. What does a microcontroller do is that it actually separates the infrared and red part and calculates a ratio of ratios. That is, this AC red means it is a pulsatile component of the red wave. This is a constant component of the red wave. This is the pulsatile component of the infrared wave, and this is the constant component of the infrared wave. So a ratio of ratios is calculated. This is then applied to a specific algorithm to calculate, to derive the number that we see on the screen. So this is how the number appears on the screen from the light to the number. I hope you have understood. Uh, so this is a very, though the device is tiny, it actually is a very smart physics. That is, it measures light, it filters signal, it applies Beer-Lambert's law all in a circuit. So I hope next time when you see a pulse oximeter, you will know the science working behind it. Thank you.